We're now going to variance and standard deviation. Let's look at this example first. The following data points are the amount of money that were found in a sofa and an armchair. Where this was the amount you got in the sofa, and this was the amount that you got in the armchair. The mean for both of them, and you can confirm it yourself, is 6. And the range, which is the max minus the min, is 11 for both of them. But these two data are not really the same. And so you might think that they are spread out the same way because their mean is the same and their range is also the same. But actually the sofa is a lot less spread out because it has data that is very close to the mean. While for the chair, the data is quite far from the mean. Therefore, we have to find some other way of calculating how spread out a certain set of data is, which is where the standard deviation comes into play. Standard deviation looks at how far away the individual data points are away from the mean. And for that, what you have to find first is the distance from the mean. So remember, the mean was 6. And what you're doing here is taking those individual data points and subtracting them by the mean. So 1 minus 6, negative 5, 4 minus 6, negative 2, and so on for all of them. And you will get how far they are from the mean. Then we want to find the average of those distances. But if we add all these numbers up, you will see we will get negative 9 here and positive 9 here. And if you want to add them all up divided by 8, we will just get 0. And you'll see that with all the data that you try finding the distance from the mean and the average of that distance, you'll always get 0. Because that's how averages work. They have the same distance in the positive direction and the same distance in the negative direction. And so we want to find a way to not have the total adding up to 0. Here currently, because we have one positive and one negative, they cancel each other out. What if we can somehow make both the differences positive? And we can do exactly that by just squaring those distances from the mean. If we square those negative and positive numbers, we will end up with positive numbers on both sides, which means there is no more cancelling out when finding the average. So if we find the average of these squared distances from the mean, we get what we call the variance of the data. And then taking the square root of that average or of that variance, we get what we call the standard deviation, which shows us how far the individual data points are away from the mean. So let's do that now. We need to sum the squared distances in order to find the mean, because the mean is just the addition of all the square distances divided by the number of data points that are there. Remember, this sign, the sigma sign, is known as the summation sign, the sum sign. And so we're going to use a lot of this notation from now on. It's better to get used to them. So finding this, we add up all of these numbers, and what we get out of it is 72. How many total data points are there? We see that there are 8 data points. And so the variance ends up becoming 72 divided by 8, which is just 9. That, remember, is the variance. It's the average of the squared sum. Now, because initially we squared the data, we need to undo that squaring that we did so that we get what the actual distance is. That undoing of the squaring by square rooting gives us the standard deviation. The sign that's used for standard deviation is this sign here, the sigma sign. And in this specific scenario, what we will get is the square root of the 9 that we got, which gives us an answer of 3. So 3 will be the standard deviation for the sense in the sofa. Now let's look at the variance in the standard deviation for the chair data, the armchair. The average, remember, was 6, the mean was 6. The distance from the mean we can find for each of these. Negative 5, 1 minus 6, negative 5, 1 minus 6, negative 4, 2 minus 6, negative 2, 4 minus 6, and so on. Finding the square of those distances will be as follows. So 25 is negative 5 squared, 25 again as negative 5 squared, 16, 4, and so on. Adding all of this up, what we get is 144. That's the sum of the squared distances from the mean. Remember, we still have 8 data points. And so to find the variance, we will take the average, which is the sum of the squared data points divided by the number of data points that are there. So 144 divided by 8, which gives us 18. That 18 is going to be what the variance of the armchair data is. Then we go into the standard deviation shown by this sigma notation, which is just going to be the square root of that 18 that we just got, which gives us 3 root 2 or 4.24. That right there in 3 significant figures will be your standard deviation of that armchair data. Now, the question comes, which one was the best stash of cash to be found? The sofa or the armchair? They both had a mean of 6 as we started off with the question, and they had a range of 11. But the standard deviation for the armchair was 4.24 and the standard deviation of the sofa was 3. This means that the sofa data had a smaller standard deviation, as we can see, showing that the values are more precise. They are more consistent around the mean. They are not very far off the mean compared to the armchair data. So having a lower standard deviation, as we can see with the sofa data, tells us that the data is very close to the mean compared to the armchair, where if the standard deviation is higher, the data will be far away from the mean, where they will average out to the mean, while here it's more of consistently being around the mean. Next, let us look at an example where we have to calculate the standard deviation and variance. So we have seen the formulas for standard deviation and variance. I'm going to use that in this example here. They've already done everything for us, where they gave us the difference to the mean as well as the sum of the squared data. Let us look at this example now, where we have to calculate variance and standard deviation from this data set that we have been given. So we've been given the individual data points, we've been given the difference with the mean, and we've given the square of those differences with the sum at the end as well. And we're told to find the mean. The mean we can find through just the first row, where they say 1 minus x bar is equal to negative 3.4 as per this data. What we get out of this is that 1 plus 3.4 is equal to x bar, which tells us that our x bar is 4.4. Then when finding our standard deviation, remember what this is the sum of the squared data, the squared distances from the mean, which in this case is 29.2, divided by the number of data points that are there. 1, 2, 3, 4, 5. 5 in this case. What this ends up giving us is 2.42, correct to 3 significant figures, and that will be our standard deviation for this data set that we have. Next up, there is another formula that is easier to work with, and it's more globally used because it requires less information. Let's look at it with this example here. So suppose we have our individual data points, and now we just have to square those data points. So 1 squared is 1, 3 squared is 9, 4 squared is 16, 6 squared is 36, and 8 squared is 64. Then what we want is the sum of the individual data points as well as the sum of the squared of those data points. What we get for the sum of the individual data points is just 20. And what we get as the sum of the squared data points is 126. How many data points are there? We see we have 5 data points. Now the formula states this. To find the standard deviation, you will take the square root of the sum of the squared data points divided by the number of data points, meaning the average of the squared data points, that's this here, the average of the squared data points subtracted by the mean of the data points squared, and that gives us our standard deviation. So a standard deviation is going to be the sum of the squared data, which is 126, divided by 5, because we want to find the average of the squared sum, minus the mean, which is just the sum of the individual data points, 20, over the number of data points, which is 5. The mean squared. What we get here is 3.03 into 3 significant figures. That right there is going to be our standard deviation for this set of data. Using this alternative formula, and you saw it was a lot faster to calculate. We didn't have to find the difference of the mean and then square that difference and all that. With that other formula, the reason it's more used because we just need 3 things to calculate it. We need the number of data points that are there, we need the sum of the individual data points, and we just need the sum of the squared data points. And we get this formula for the variance. And remember, square rooting it will give us the standard deviation. And if you want to remember what exactly it is the mean of the squares minus the square of the mean. Next, we're told to find the standard deviation of the values of x correct to 3 significant figures. So remember, this is the data point, and this is the times it's repeated. Firstly, what we need is our n. How many data points do we have in total? And that is just the sum of the frequency, which is just 13 plus 28 plus 10, which gives us 51. Then what we need is our sum of the individual data points, which is just going to be 12 times 13 plus 14 times 28 plus 16 times 10, which gives us 708. And finally, what we need is the sum of the squared data points, which is equal to 12 squared times 13 plus 14 squared times 28 plus 16 squared times 10. This gives us 9,920. And now we can use our formula. Mean of the squares minus square of the mean. Mean of the squares means the average of this, which is 9920, divided by n, which is 51. Then subtracted by square of the mean. So the mean of this, 708 divided by 51 squared, that gives us the variance. We wanted to find the standard deviation, which means we will then square root that value. What we get here is 1.34 correct to 3 significant figures, which gives us what our standard deviation is. In the following example, we are told to calculate an estimate of the standard deviation of 20 children from this data set, where we're told that the height in meters of the first group is from 1.2 to 1.4, second group is 1.4 to 1.5, and third group is 1.5 to 1.7. And we're given the number of children in each group. Again, in this case, because we don't have specific data point, that's why you're going to find an estimate of the standard deviation. We did the same thing when finding the mean earlier when we did measure central tendency. And we use the middle data point in each group as our data point representing that group. So in this one, the data point representing the group will be 1.3. That will be the height that we are going to use. For the second group, it's going to be 1.45. For the third group, it's going to be 1.6. And we're going to use these 3 estimates for the representation of the respective groups. So, standard deviation, you need the n first, which is the total number, which is just the sum of the frequency, which is just 2 plus 12 plus 6, and we were given that initially as well, which is 20. Then we need the sum of the individual data points itself, which is 1.3 as our representative from the 1.2 to 1.4 group, times the frequency of 2, plus 1.45 times the frequency of 12, plus 1.6 times the frequency of 6. What this gives us is 29.6. Then what we need is the sum of the squared data points, which is just 1.3 squared times 2, plus 1.45 squared times 12, plus 1.6 squared times 6, which will equal to 43.97. Then what we're told to find the standard deviation is the square root of the mean of the squares, so the average of this thing, so 43.97 divided by 20, minus the square of the mean using this value, so 29.6 over 20 squared. What this ends up giving us is 0.09, and that's going to be our standard deviation for this data set. Following example, we're given that n is 25, the sum of x is 275, and the variance is 7, and we are told to find the sum of x squared. Now remember, variance of x is equal to the mean of the squares, so sum of x squared over n, minus the square of the mean, so sum of x over n squared. The variance we were told was 7 is equal to the sum of x squared, which we are finding, over 25 minus 275 over 25 squared. This ends up giving us 7 equals to the sum of x squared over 25 minus 121. Add 121 on both sides, we get 128 is equal to the sum of x squared over 25. And we can multiply by 25 on both sides, we get that our sum of x squared is equal to 3200. Next, when we are given combined data and we want to find the variance and standard deviation of that combined data, then we do the following. In order to find the mean, we did that previously, where you have to take the sum of each data set and then divide by the total number of data points combined from both data sets, which sums up to this formula here. And that is going to be used as our mean. Then to find the variance, remember, we need the mean as well, because the second part where you're subtracting requires the square of that mean, which is what we see here. The first part is the mean of the squares. So again, you're going to sum up the squares from both data sets. So sum of x squared plus sum of y squared. You're going to find the average of that. So divided by the total number of data points that are there. And we get this formula for our variance. And again, standard deviation, we're just going to square root that variance to get that. Let's look at an example. The heights of 10 boys are summarized by the following. The sum of x is 1650. The sum of x squared is 275490. Similar thing is given for y, where 15 girls are summarized by the following sets of data. Then we are told to find the standard deviation of all the 25 children together. So firstly, we want to find the mean of all the 25 children together. And for that, we have to add up all the data points from both sets. So sum of x plus sum of y divided by the total number, which is 25, the total number of kids that are there. This will give us 1650 plus 2370 divided by 25, which gives us 160.8. That is going to be the mean of the height of all the 25 children put together. Then you also want to find the mean of the squares of the heights. For that, we do sum of x squared plus the sum of y squared divided by the total number of children that are there, which is 25, which gives us 275490 plus 377835, all of them divided by 25. This ends up giving us 26133. And remember, for our standard deviation, we're going to take the square root of the mean of the squares, so 26133, minus the square of the mean, so 160.8 squared. This ends up giving us 16.6 as our standard deviation corrected to 3 significant figures. Using the formulas that were just given above and using the information that we did in our last topic of measure of central tendencies. Finally, similar thing about the combined data, but in this case we have to find y bar, which is the mean of the y datas, because remember, y is the girls' marks and we have to find the girls' mean marks, which is just the sum of y over n. That's what we have to find. So remember, we are given that the standard deviation of all of these students combined is 10. Therefore, the variance is going to be 10 squared, which is going to be 100. And so what we have is the variance of both x and y combined is equal to the sum of the squares divided by the total number, which in this case is 80 plus 120, which is 200, minus the square of the combined mean, which is sum of x plus sum of y over 200 squared. The variance we know is 100, and that is equal to the sum of x squared, which we know is 424320, plus the sum of y squared, which is 352130, which is divided by 200. Then we subtract by sum of x, which is 7020, plus sum of y, which we don't know, divided by 200 squared. What we end up getting after rearranging and finding the value for this fraction is the following: 7020 plus the sum of y over 200 squared is equal to 3782.25. We can square root both sides, and what we get from that is 7020 plus the sum of y over 200 is equal to 61.5. We can times 200 on both sides. We end up with 7020 plus the sum of y is equal to 12,300. Then subtract 7,020 on both sides, and we get the sum of y is equal to 5,280. Remember what we needed? We needed the mean, which was the sum of y divided by n. What n specifically? The girl's n. So 80 in this case, or ny in this case, if we are using the notations. So we have to divide this by 80. And that will give us our mean mark for the girls to be 66. So we sort of reverse engineered this formula in order to get this specific part of it.